Okay, so we're going to look at indices. I'll do the whole version, almost the whole version, so I'll go all the way up to year 10 right now. Because indices, the only thing you're going to learn in year 9 is the fraction index, and usually you're not meant to get that taught that until year 9 and year 10, for example, but I might as well just go all the way since I've got this, and we'll make a formula sheet for you that way. Alright, let's choose a different color now. Let's go with this one. Alright, here we go. So the very first thing you learned, so let's look at the laws first. The very first thing you learned was a to the power of m times a to the power of n. When you multiply bases that are the same, so for example the a and the a here, what do we do to the indices? We will add them up, right? And similarly, of course, when we divide bases that are the same, we subtract. Okay, so when we got bases that are the same, we add the indices, and bases that are the same, and we're dividing, we take away the indices. Okay, and then we've got a power to a power. Well, actually, let's write an example for this. Okay, so our example will be in green. Alright, so an example for this one would be something like x to the power of 3 times by x to the power of 5. That equals 2. Well, since the bases are the same, then that's going to be 3 plus 5, which becomes x to the power of 8. Cool. And same thing with this one, x to the power of 9 divided by x to the power of 3. Again, since bases are the same, 9 take away 3, and that gives you x to the power of 6. Any questions about that?
No.
Okay. Now let's go with a power to a power. So it's called raising powers, and that looks like just like this. If I've got a to the power of m, but then it's all to the power of n, we multiply the indices. Okay, we multiply the indices. So again, the example for that one would look something like this. Imagine it's x to the power of 3, and then all to the power of 4. So you don't add this time, that's why I kept saying bases are the same, so you're meant to see 2 for you to add. That's the way I want you to start seeing it. When you see 1, you go, okay, it's not add, it's probably something else. And it's not 7 here, and I don't do a little mistake like that, it's x to the power of 12, because you times, right? 3 times 4. Now, a common mistake that I've seen is when I give you a number with it as well. Now, let's write an example like that. So imagine I've got 2x to the power of 3, all to the power of 4. Now, the question you got to ask yourself is this 2 right here attached to the 4? Well, because we've got brackets right here, that 2 is definitely attached to the 4. For it to not have been attached, it would have looked like something like this. The only thing that's attached to the power of 4 is the x cubed now. The 2 is on the outside. So brackets are really important, okay? So 2x cubed all to the power of 4. That answer to that is 2 to the power of 4, x to the power of 12. Now if you want to know why it's 4, remember me saying you want to multiply the indices. I never said anything about numbers. I didn't say multiply the numbers. I said multiply the indices. Now you got to ask yourself, what index is here for 2? If I write nothing, we imagine it's always a 1. That's it. So there's a 2 to the power of 1 there, and then look at this. 1 times 4. 1 times 4 is 4. Right? 1 times 4 is 4. Whoops. And then 3 times 4 is 12. And that's how I got those. So it's not 2 times 4, be careful, it's 2 to the power of 4. Okay? So don't look at numbers, look at indices. You understand the difference between those? So these are numbers, these are indices. Okay? Big difference. So you multiply the indices. Alrighty. So the answer to this here is 2 to the power of 4 and x power 12. And if it says in index form, so this is called index form. If it's said to simplify, well, obviously you must put that into your calculator. 2 to the power of 4 is 16. X power 4. So that's in simplified form. So if you said simplify, simplified form. Cool. Okie dokie. So we've done, alright, bases are the same, we add, bases are the same when we divide, we take away, power to a power, when we're raising powers, we multiply, and then obviously if it's attached, not attached, that's something you got to be careful of, okay? And that's a nice little concept to just understand for anything in the world. Brackets are massive. If it's attached to the brackets, then everything in that bracket's affected. If it's not, then it's not affected with the bracket. Cool. Alrighty. The next law. So that's law 1, law 2, law 3, law 4. Nice and easy one. Anything to the power of 0 is equal to 1. As long as it's attached to the 0. Why I say that? Because we give you questions like this, and again, I've already got some people out of the equation here. Here we go. If I write, nice straightforward one, I'll give you an example like this. Okay, so if I was to write 2x to the power of 2 or to the power of 0, well, I don't really care about what this is anymore because it's all to the power of 0, and I know anything to the power of 0 is 1. So the answer to this is just simply 1. But I could just slightly change this equation up and write 2x squared to the power of 0. Now, is the 2 attached to the 0? In this case, it's not because it's only attached to the x squared due to the brackets. So that 0 is only attached here. So x squared to the power of 0 is 1. So this part here is equal to 1, right? But the whole thing doesn't equal to 1. So since this part equals to 1, and then we obviously assume, as always, there's an imaginary times there. So the answer to this is 2 times 1, which equals to 2. Okay? So you got to look for what's attached and what's not attached. So if I gave you another example and I wrote 8x0 minus 8x0. Okay, so that's example 1, example 2, example 3. So 8x power 0 minus 8x power 0. So again, let's walk through it together. We go, is the 0 attached to the 8 in this case? Well, no, it's only attached to the x because there's no bracket, so we're only assuming it's for the x. So that part there is equal to 1, right? And then that becomes 8 times 1. Just that part equals to 1, I said. I didn't say the whole thing equals to 1, just that part equals 1. So we got 8 times 1, which is obviously 8. We take away. And then this is all to the power of 0. So this 8 is attached to the 0 because of the brackets. So then that's anything to the power of 0 is 1. So that's just 1. 8 times 1 is 8. 8 take away 1 is 7. Okay, so you got to be just careful of, is it attached, is it not attached? That's the big thing that you want to just understand out of today. Cool. Okay, let me just say something.